So this doesn't look, there's nothing I can do with this as it stands. That does not fit our short list of antiderivatives, right? So we're going to probably have to make a U substitution to make this work. What would our choice of U be? 2x minus 1. Okay. So if we let U equal 2x minus 1, what's du equal to?
2 dx.
Yeah, it is. 2 dx. Very good. Okay. Did I write that down correctly? Yeah, I did. Okay. Good. All right. So then, if I make my substitution, well, oh, but hold on, one part here that I got to be aware of.
There's no 2.
There's no 2, right? So if we solve for dx, dx just equals 1/2 du. Everybody agree? Okay, so then if we do our substitution here, what do we get? So on the bottom, we get a square root of
U.
Good. Okay. Which we could just rewrite as a u to the minus 1/2, right?
Yeah.
On the top, we get our dx. Our dx is a 1/2 du, but we're stuck with an x, aren't we?
Yeah.
We had an incomplete substitution. So what's our strategy?
Solve for x.
Good. Okay, perfect. We're going to solve for x right here, right? So if I solve for x, I'm just going to add 1 and then divide by 2. Everybody agree? So x equals u plus 1 over 2. So if I make that substitution, then I've completed the substitution. Now the 1/2, what can I do with the 1/2? I'm multiplying by another factor of 1/2. So what's probably the best thing to do with that 1/2? Pull it out front, right? Okay. So I'm just going to get 1/2 times the quantity u plus 1 times du divided by the square root. So yeah, pull it out front. So I've got a 1/4. Oh, I got to change one thing here too. And so this is from x equals 1, right, to x equals 5. Okay. So then what are we going to get? Okay, so now we've got what we had before, but we've got a u plus 1 there, right? In place of the x. Right, from x equals 1 to x equals 5.
Wait. Square root u.
Oh, whoops, u, sorry. Yep.
Can't we just do that now? Put it on top?
Put what on top?
The u.
Yeah, we can.
U negative 1/2.
Okay, we can. So let's go ahead and we're going to have to rewrite this, aren't we? Right? But we can do that now because look what we did. We traded a square root of a bunch of stuff for a square root of a single variable, which we can distribute, right? Okay. In this case, we're distributing by dividing each term by u to the 1/2, right? So in other words, we're splitting this fraction up. Same idea, okay? So then, what is that? I'm going to kind of partition this off here. So there's all our u's and du's. There's our substitutions, right? So then we end up with 1/4 times the integral of, what's the first term going to be? What's u to the 1 divided by u to the 1/2?
U to the 1/2.
U to the 1/2, right? We agree? Because
Cookie minus that.
Because if I divide like bases, I subtract the exponents, right? Okay. Keep in mind, let me write it this way. How about this is this u on the bottom, the square root of u is really just a u to the 1/2. So u to the 1 divided by u to the 1/2. And let's write it here. U to the 1 divided by u to the 1/2 equals u to the 1 minus 1/2. Right? So this stuff right here becomes that, right? Make that a better.
How do you do that with the 1 over?
Okay, Okay, so what about that? What's 1 divided by u to the 1/2?
U to the 1/2.
No. That's the same thing as 1 over u to the 1/2. What is, if I have a positive exponent on
U
the
to the
bottom?
negative 1/2.
U to the negative 1/2, exactly. So then this becomes plus u to the minus 1/2 du. So here's, that stuff just became that, right?
Yeah.
Okay. And my limits of integration are still the same. X equals 1 to x equals 5, right?
You don't have to put the du over u to the 1/2.
No, the du is, remember, the du is just multiplied by everything, right?
Oh, okay.
Yeah, that's why I have parentheses around everything in here.
I don't get why the first one is not negative and the other one's
Because I have, this is like saying u divided by the square root of u. What is something divided by its own square root? Square root, right? U divided by the square root of u is just the square root of u. Because the square root of u times the square root of u is u. Sounds like that sounds like a combination of bad philosophy and bad grammar. Wrapped into one. Yeah. Right? Yeah. Yeah. Okay, does that make sense?
No, I'm confused on why the 1/2 is positive.
Well, because if I divide u to the 1 by u to the 1/2, what's our rule of exponents? When I divide like bases, I just subtract the bottom exponent from the top.
Right? The second one, the same thing.
No, the second one is just like saying this: 1 over u to the 1/2 is the same as u to the minus 1/2.
Oh.
Right? Okay. And really, what I could do there, if I wanted to, wouldn't make any sense. But I could call 1 is just u to the 0, right? So I could do u to the 0 minus 1/2 also. Either way, I'm going to get u to the minus 1/2. Okay? All right, so now we do our antiderivative, right? And that's going to give us, so we get our 1/4 out front. Now what's this first antiderivative going to be? What's the antiderivative of u to the 1/2?
3/2.
Okay, u to the 3/2 divided by 3/2, which is really times 2/3. So we're going to get 2/3 u to the 3/2 plus, what's the antiderivative of u to the minus 1/2?
1? No. Half? No.
Yeah, u to the
Half.
1/2, right? Because negative 1/2 plus 1 is 1/2. U to the 1/2 divided by 1/2, which is the same as multiplied by 2. Yeah. So we're going to get 2 u to the 1/2. And that's going to be evaluated from x equals 1 to x equals 5, right? Because we're doing a definite integral. And so then it looks as though we're going to need to just go ahead and reverse the substitution, right? Okay, so we could rewrite this then as 1/4 times 2/3, what's u? U is 2x minus 1 to the 3/2 plus 2 times 2x minus 1 to the 1/2, evaluated from 1 to 5, right? So what do I get if I plug 5 into everything? So this is just going to equal, and I'll put the 1/4, how about in front of everything, right? So when x equals 5, I'm going to get 2 times 5 is 10 minus 1, right?
Yeah.
So what's 9 to the 3/2? What's 9 to the 3/2? 20. So what is it again?
27/2.
It's 27.
Oh, 20. Wait, why
Yeah,
not?
because 3/2 power, what's that mean? The 1/2 power is a square root, so the 3/2 power is really just a square root cubed, right?
Yeah.
So the square root of 9 is 3, cubed is 27. Okay. So we're going to get, from this term right here, we're going to get 27 times 2/3 is 18, right? So I get 18 plus And then here the 2 times 5 minus 1 is 9. Square root of 9 is 3 times 2 is 6. Right? So when I evaluate at 5, I get this. Minus, now what do I get at 1? When I plug 1 in for x, I'm going to get 2 times 1 is 2 minus 1. Well, 1 to the 3 halves is what? 1. So 1 times 2 thirds is 2 thirds. And then same thing here. 2 times 1 is 2 minus 1 is 1 to the 1 half is 1 times 2. So that's my answer. Okay? Whatever that is. So if I add all that stuff up, that's the area. Yeah.
How do we, isn't there a plus C in there?
No,
No.
not indefinitely. So this is 24, and this is, what is this? So 24 minus 2 and 2 thirds. So 24 is the same thing as 72 thirds minus 8 thirds is 64 thirds times 1/4 is 16 thirds.
Good job.
Okay, so that's my answer, right? Okay, so there's a better way though. We had no, seriously, there's a small shortcut here I want you to see. This is actually an easier problem than what you did yesterday. I'll tell you why. Because look what we could have done here. What we could have done, rather than having to shift back to x's, why do that? Why not instead just change the limits of integration and rewrite them in terms of u? Okay? So we could have said up here, instead of x equals 1, no, let's not do that. Let's not rewrite these in terms of x's, let's just rewrite it in terms of u's. Okay, so in other words, when x equals 1, what does u become? X equals 1. So look down here and tell me. Yeah, when x equals 1, u is 1, right? Okay. So down here we get u equals 1. And up here, when x equals 5, u equals 9, right? Okay. Now that's pretty amazing in a way that works the way it does. Okay. It's very important that it does. But think what we did. We took a totally different function. We said that the area under this curve in x space is the same as the area under this curve in u space, right? And I don't have to reverse my substitution anymore, right? What I can do instead is I could just stop. Well, you'll see here in a second. I've got to rewrite all these. So this looks like, oops, forgot one. So now we're just going to go from 1 to 9 with u's. And so back down here, I didn't need to reverse this substitution. I could just do this. How much easier? Right? So now I can skip all of this garbage, and I could just say that this equals 1/4 times, well, what's the value of this whole thing when u equals 9? Well, this is going to be 2 thirds, that's 27, just like before, right? So 27 times 2 thirds is 18 plus square root of 9 is 3 times 2 is 6.
Oh, so instead of putting in 2x minus 1, you're just putting in 9.
Yeah, I'm just putting in 9 and 1, right? Minus, if I evaluate this at 1, I'm just going to get 2 thirds plus 2. Oh, look, that's the exact same answer we got there. Yeah. Right there? Okay. You see the trick?
Yeah.
Okay. Now I want to demonstrate for you. That this works. When you see something really cool here. Okay, so I gotta go up a little bit. So let's look at our original problem, right? So if I go,
Oh yeah, we could just put this on our calculators.
yeah,
So
because,
we didn't have to do all that.
well, no, you did, because I'm not gonna let you use your calculators on the test. So we're just gonna put in. Everybody, watch please. So we're gonna put in this function. So we've got the fraction x divided by the square root of, square root right there, square root of 2x minus 1, right? Okay, so we're going to do that function from 1 to 5, okay? We're just looking at the area under that function from 1 to 5, right? So let's go ahead, let me make our window go from 0 to 10. And let's go zoom 6. Oops, I messed something up there. 0. 2, 0. Okay, so there's my first function. Let's go ahead and calculate, so second calc, we'll calculate the area under the curve from 1 to 5.
Wait, you put second calc 7?
Yeah. So I get 5 point, well that's what we got, 16 thirds, right? 5.3 repeating, same thing. Okay? So now let's do the other one. Now let's do this guy, right? Kind of got a little messed up there, but we could put in the other function, which was, I'm going to make it x because we don't have u's on the calculator, but same idea. So we're going to do the square root, or excuse me, we're going to do the fraction, x plus 1 over the square root of x.
What about times 1/4?
Times 1/4. Very good. 0.25 times.
You put, is there a point in the 25?
Maybe not. I'll go back and put one. I think I missed it. So we got x plus 1 divided by square root of x. Oh, too far. Not get crazy. Okay. Oh, what? Oh, that's what okay, so I think that's what it is. All right. So there's the first one, right? And there's the second. There we go.
Mine's not easy. Wait, which press zoom on?
I hit zoom 0.
Oh,
Okay.
why should I?
We'll do one more thing. I'm going to change the window so y min is 0. Actually, we'll go to negative 0.25. Okay, there's the first one, right?
Why is it different?
Well, it's different because we changed the function, right? Okay, but look what we're going to do. Let's go back and recalculate. So let's do second calc 7, and we're going to do it for this function from 1 to 5. Okay, so there's an area. The blue area is 5.333 repeating, right? Now let's do second calc 7, and let's do the red function from 1 to 9. What do you know? Same area. Okay, which one was easier though? The red function was easier to deal with, right? Okay? Alright, so let's try one more of those. Let's try, how about...
Is it necessary to know how to do it on calculator?
Yeah, I'll tell you what I'll do. Here's what I'll do.
It looks kind of
I know you guys will like
Yeah,
this.
remember that.
Here's what I'll do. I'm going to give you a test in 2 parts, but the 2 parts are going to be a non-graphing calculator part and a graphing calculator part. It should be,
maybe like 3 questions long.
it won't be real long. But I mean, the graphing calculator one, honestly, all it's going to be is just being able to do, like I'll have you maybe do a discrete sum, not a hard problem, just do a discrete sum on your calculator, so you show me you know how to do it. Then do a definite integral. Okay, so you got, that's what I'm saying, you can just do a couple problems like that.
How do
Where
we do this for example?
you just go to, all you have to do in your calculator to get a discrete sum is you go math, and then you go to the bottom of the list to summation. So 0. Just fill in the blanks.
Oh, okay.
Okay?
Yeah.
All right. Okay, I don't think it. Okay, how about okay, let's look at this one. Okay, what's our u substitution going to be this time?
X squared plus
X squared plus 1. Okay, good. So we'll let u equal x squared plus 1. So what's du?
2x dx.
Okay, so we've got an x dx. So x dx is just a 1/2 du, right?
Yeah.
So then this is just going to give us the integral of u squared times 1/2 du, right? Okay, now I want you to notice something here. What happens when we plug in -3? Okay, 10 to what? 10 to 10. So what's the answer?
0.
0.
Would that have been the answer if we would have?
Yes, it would have. Now I want to see if you can tell me.
Quicker way to find out.
You're right, it is. Okay, but what I want to show you here, and you got to really pay attention to this is huge. This is a rule that'll save you a ton of time. Is that what if we wouldn't have been able to make that substitution so easily? Okay, we still could have done this. Here's how. If I take the integrand, so everything right there, right? If I take that integrand and I expand it out, what am I going to get? So I'm gonna get x to the fourth times x, so I'm gonna get x to the fifth, right? Plus 2x squared times x is plus 2x cubed, plus 1 times x is x. Right? Okay? From negative 3 to 3. Now, what can you tell me about that function, about the symmetry of that function? It's odd, right? That is a function with odd symmetry, right? It's an odd function. So if it's an odd function, think what this is going to always do, right? If it's an odd function, that means, like, let's take just one as an example. Let's take, for example, x cubed, an easier one, right? X cubed just looks like this, right?
Yeah.
If I have symmetric limits of integration, think what we're always going to be doing. So if I go out to like 3 here, let's just say that's 3 hypothetically.
Oh, they're going to be subtracted.
Yeah, they're always going to be positive and negative, aren't they? Right? Exactly. And so look what happens. I'm going to get some positive area here, and I'm going to get exactly the same amount of negative area there. So they'll always add to 0, right?
Is that only with even?
Only with an odd function, right? So if I integrate, if I'm adding up the area under an odd function over symmetric limits of integration, the answer is always going to be 0. Yeah, okay, that's always true, right? So then we end up, and that can save you a ton of time. So what happens then if you've got something like, let me just write that down real quick. So we end up getting, if f is odd, then the integral of f of x dx from negative a to a is 0, right? Okay, agreed? Okay. How about one like this? Oops. I mean, this is right in your textbook too.
Okay.
Okay. So let's try another one. Okay, what's the answer to that one?
It's not 0.
It's not 0. You're right. Well, what's the? We can do this one. What do we get? So we're going to get the antiderivative is x cubed over 3, right?
Yeah.
So I'm going to get 1/3 x cubed evaluated from negative 3 to 3, right? Okay. So that's equal to 1/3 times, let's see, so 3 cubed is 27
Yeah.
minus negative 3 cubed is negative 27. So I get 27 plus 27 is 54 divided by 3 is 18, right? Okay, I want you to compare that to something. Okay, well, we already did the math, right? We know that the calculus gives us this.
47 divided by 3.
Right? So that would give us 1/3 times 27 minus 0, which is 9. Okay, is that math? What kind of a function is x squared?
Positive.
What kind of symmetry does it have? Even, right? Has even symmetry. Well, think about what that must look like in terms of a graph of the area, right? If it's an even function, that means that's folding symmetry about the y-axis, correct? So if I'm going to do a function like x squared from negative 3 to positive 3, well, look at these two areas. Aren't they going to be completely symmetrical?
Yeah.
So then how could I make it easier?
Solve for half of it and multiply.
Yeah, just go from 0 to a and double it, because 0 is a really easy number to evaluate, right? So the other trick we have is we could then say if f is even, the integral of f of x dx from negative a to a is just 2 times the integral from 0 to a. So then how could we be really tricky about a problem like this? What if we do the integral of pi x to the fifth plus x to the fourth minus 3 x cubed plus x minus 5 from -1 to +1. What could I do? Is that function odd or even?
No.
It's neither, right? Okay, but couldn't I break it up into two functions? Right? Well, because I've got, when I have both even and odd exponents, if there are parts that are even and parts that are odd, then it's neither, right?
Question.
Yeah.
Is the pi meant to go to just x to the fifth or is it everything?
No, just x to the fifth. Yeah. Okay, so then look what this becomes. We could split this up into an even part and an odd part, right? So let's break this up into, so I'm going to pull out the odd parts. Pi x to the fifth minus 3x cubed plus x to the 1, right? Plus the integral from -1 to 1 of all the even parts. So that's just those two, right? That's x to the 0, and 0 is even, right? Okay, what are those? What's the sum of, that's odd, right?
Yeah.
So what's the area under that curve? 0, because it's over symmetric limits, right, of integration. So this one, this whole thing, goes to 0. Right? So all we'd have to do then is just trade this for 2 times an easier integral. Right? And that's no big deal. Okay? Does that make sense? Okay? 2 minutes is all we
Wait,
have?
why is it 0 to 1? Yeah.
Well, because I have an even function over symmetric limits. So instead of adding up both of them, I'm going to get the same amounts on the left and the right of the y-axis. Right? All we're going to do is, where's that picture? Wrong picture. That picture. Right? This area is the same as that area. Right? So why not just add up this area and double it? See? So it's this trick, whoops, right there.
Okay.
Okay? All right.
Thank you.
Mm-hmm.